All right, so welcome to this next video. In this next video, we are trying to do some miscellaneous questions involving differentiability. So let us look at this question. It says determine the values of a such that f of x is continuous at x equals to a, and then check if it is differentiable at x equals to 2. So I think this is quite straightforward for us to do. The first thing that we are just going to check is if the function is continuous. So if the function is continuous, we know that the limit as x tends to a from the left, so we turn in that function from the left, this must equal to the limit as x going to a from the right of f of x, and this must equal to f of a. So this is what we know about continuity. So that's what we will try to do first. So we know that if we are approaching the function from the left, a from the left, we will deal with the x plus 1 as the function. This must equals to the limit as x tends to a from the right. In our case, it's minus 2x squared plus 3x plus 5. And this must therefore equals to f of a. Since f of a in this function it is less or equals to, then it will just be equivalent to what we get from the left. So once we apply a limit, this becomes a plus 1. This becomes minus 2a squared plus 3a plus 5. And therefore, we want to solve for a. So this is minus 2a squared. If we take that across, this becomes plus 2a. And if we take the 1 across there, that becomes plus 4. And this is just a quadratic equation with which you can solve for yourself. And this quadratic equation, when you solve it for yourself, you can quickly work out that you get two solutions. You get that a is equals to 2, or the other one, you get a is equals to minus 1. So therefore, those are your two solutions. So the other thing that they wanted us to do is to check if this is differentiable at a is equals to 2. So we remember that we then have a condition for differentiability. So the condition for differentiability is that the limit of the derivative needs to exist. So we want to check the limit as now x tends to 2 from the left of the derivative. So we'll meet up with that function. The derivative there is equals to 1. And therefore, we will check the limit as x tends to. So wait, let's try to do the derivative there as a whole so that you guys see where that comes from. First of all, so we know that the derivative from the left will take the limit as x tends to the derivative, but the derivative of f of is therefore equals to 1, and the derivative on the other side is the derivative that we get is minus 4x plus 3. And what we then do, we apply limits, so this is equals to 1, and the derivative of that, if we then substitute 2 there, we get minus 4 times 2 plus 3. And if you are able to calculate that quickly, you'll get that this is minus 5. And therefore, you can clearly see that the two limits are not equal. So if the two limits are not equal, that means that the function is not differentiable. So remember now, we say that the limit as x tends to 2 of the derivative does not exist. So this does not exist. So therefore, we say that f is not differentiable at x is equals to 2. All right, so I hope this has made sense in this series on how we have done things. And I hope now the concept of continuity and differentiability are much more clear. The next time you'll see me doing questions of this type will be when we tackle in some past paper questions. I hope you've enjoyed this series, and therefore I will see you in the next video.